Yeah, my name is Mile Mitrovich. I'm Executive Director of Data Science in Verifiable Lab. My colleague Lyosha in previous presentation talked more in detail about Verifiable Lab. I'm native in Serbian, but I also speak Russian. And in the end, if you have some question, don't hesitate to speak in Russian. I will answer in Russian, no problem. Yeah, more about me you can find on my Telegram channel and my LinkedIn profile. And of course, feel free to join to my channels. And today I will talk about reasoning in large language models. Exactly, I will talk how we use reinforcement learning technique to fuel reasoning in large language models. But before I'm starting this presentation, I would like to ask all of you to raise your hand who is working with large language models. Okay, great. Who is familiar with reinforcement learning? Nice, nice. Okay, great. Thank you very much. Let's start this presentation. Yeah, I will start this presentation with brief introduction to large language models. And there is the first question. What are the large language models? According to definition, the large language models are the probabilistic models that assign probabilities to the sequence of words. But what does it mean? In general, we can consider large language models as conditional probabilities, where for the given some event, for example, in case of LLM, it will be some context or prompt, we can predict the probability of the next event. And again, in the case of LLM, it will be the next token. But to be easy to understand what I'm talking, let's say that one token is just one word, and it means that we can predict the probability of next word from vocabulary on which this LLM is trained. And for this concrete example, for let's say given context Moscow is in, the next likely word, predicted word, will be Russia. And thus this word predicted return back to the context. It means we spread context or receive new context. And for this new context, we predict the next word, and it is repeating sequentially. And I can say that it's all background about how large language model works. But to make better sense how large language model works, there's the second question. How are LLMs trained? And I think if we understand how they are trained, we much more better understand how they worked. And in general, there are two common stages in training LLM: pre-training stage and SFT or supervised fine-tuning stage. In pre-training stage, we gather a lot of data from internet. These data are raw unlabeled data or unlabeled text. And after pre-processing this data, we train LLM on this data. But training on this data is computationally expensive and high costly. It means that we need to pay a lot of money. What exactly it means? We need a lot of hardware resources, a lot of GPUs for training that. But also in previous presentation, Evgeny, I think he talked about maybe this quantization and maybe it will be improve everything in the future. But yeah, for now it is so expensive. Just a big corporation can do this, like Microsoft, OpenAI. Also in Sber, we have Sberbank, we have GigaChat, maybe some of you use, but also we also do this pre-training stage. But after pre-training, we receive so-called base model. And this base model is not so useful for human. Because this model has just few capabilities. We can use this model just to complete text or for few short capabilities. And because of that, there is the second stage. Why laser doesn't work? Okay. Okay, don't worry. There is the second stage. In the second stage exactly implies firstly gathering label data set. And gathering label data set further implies hiring human annotators who label this data. And yeah, in SFT, what we are doing exactly, we take base model from the first stage. We continue training this base model on this label data set, and we receive so-called assistant or instruct model. And the main idea of this SFT approach or stage is to, and also training on label data set, is to create model that imitate human, to behave like human. Because with this model, we can do a lot of things. We can do classification, summarization, translation, question and answering, also creating a lot of chatbots and so on. But recently, or better to say a few years ago, appeared the third stage. And there is a lot of definition about third stage, but because today we talk about reasoning, I will call this stage reasoning stage. And in the reasoning stage, we can exactly consider reasoning stage from inference side and training side. From inference side, there are several techniques such as inference time scaling, RAG, agents that somehow can improve reasoning in large language models. But today we'll focus on reasoning from training side. Exactly, we'll talk about reinforcement learning technique that continue training of base or assistant model, and on this way improve reasoning in large language models. But before we move to talk about reasoning LLMs, we need to talk about problems that we have in supervised fine-tuning stage or second stage. And there are two problems. First problem is related to unverifiable tasks, such as creative writing, poetry, summarization, and this problem is related to human. It means that if you have some input like write haiku about Moscow, there is a big probability that this input will not, for example, this, LLM will generate some input, but some output. But there is a big probability that maybe I will not like this output, or some of you will not like this. And because of that, this problem is actually problem of alignment or problem satisfying human preferences. It is the first problem. And the second problem is related with verifiable tasks such as math, coding, and exactly tasks that have concrete answer. And this second problem is related with LLMs. What does it mean? It means if you have some complex task, it can be some mathematical task, and if LLM answer this task in just one word, or maybe two words, or just one sentence, there is the big problem that this answer will be incorrect. And exactly it is case where we start to talk about reasoning. And what is the reasoning in LLMs? It is a process of answering questions that require complex multi-step generation with intermediate steps. What does it mean? For example, if you have some complex task, and for LLM, it is much more better to answer this task by generating more tokens. In this reason, it is called a reasoning step, and in the end, to provide final answer. While it is better for LLM because LLM and human process information differently. And if you remember from beginning when I talked how LLMs work, I said that LLM predict and generate token or word in sequence. And exactly because of that, by generating more tokens and the end providing final answer, there's a big probability that this final answer will be correct. And I can say that it is all idea about about reasoning in large language models. And now we'll talk about reinforcement learning technique. In general, reinforcement learning is just like one type or one direction of machine learning, and we can relate reinforcement learning exactly. It is often related to robotics and automation. And when we talk about reinforcement learning, we just can imagine like autonomously movement of robots. And in reinforcement learning terminology or foundation, we have some agent. It is like some robot. Agent makes some action, like robot makes some movement. Also, we have environment. It is just like external area or external environment that reward each action of agent or each movement of robot. We also have state. State is just like next position of agent or robot. And this process here also we have policy. Policy is just strategic planning of next actions. And this process is iterative. Exactly, this is iterated during the time. But there is question how we can relate reinforcement learning paradigm in the context of large language models. And it is nothing difficult because LLM we can present like agent or policy model. Also, we have this action. It will be just completion to prompt. Exactly, it will be just next generated word or token. Environment, it will be reward model. For now, I will in the next few slides I will talk more about reward models, but for now it is just reward model. And state, it will be the next prompt. Exactly when we predict next word or token, we return to back to the prompt, and it is like next prompt that we receive. It is state, and I think that I cover all terminology of reinforcement learning in context of large language models. And now we can talk about how we use reinforcement learning in practice to train large language models. And in general, there are two common approaches, reinforcement learning approaches for training LLMs, like PPO or proximal policy optimization, and GRPO, like group relative policy optimization. Firstly, we'll start with PPO because this approach is more older, because developed in 2017 from OpenAI. And here also we will try to figure out how using reinforcement learning paradigm in training large language models. What is going here? For example, firstly, what we have this base or instruct model from the first or second stage. We create copy of this model and we receive policy model. This is model that we will train exactly. We also have value model and reward model. They are also both large language models. Reward model is often the same model like policy model, while value model in PPO is LLM, but it is often LLM with much more less size or less number of parameters, because value model may update during this reinforcement learning training. And reward model, it is just trained offline. It is trained on human preference data. And what is going here for the given prompt, we send this prompt to policy model. For this prompt, policy model generates some output. Reward model and value model in PPO. Okay, value model just estimate expectation reward, but let's say that we will not go deeply in details. That value model, reward model together return back reward score of output. And there is also loss function. Loss function try to maximize this reward score. And according this loss function or maximizing reward score, we update parameters in this policy model. Also, there is some divergence constraint. It means that we don't want that these parameter updates a lot. Exactly, we want just to keep updating this parameter, because there is possibility that policy model can forget everything from the first and second stage, and we don't want to our model, new model, to forget all this knowledge from the first or second stage, and because of that we have this divergency constraint in updating parameters. And after first iteration, we generate the next output. The next output is again receive some score. According to this score, we update this model, and it is repeating many times. And yeah, it's all how we use reinforcement learning for training large language models. But in last year, in 2024, the guys from DeepSeek, they developed new approach, so-called GRPO. And this GRPO approach exactly is just improvement of the PP approach. What they did, they remove this value model, and instead of generating just one output per iteration, they generate many outputs, or like group of outputs. And also in loss function, they try to maximize the average reward of these group rewards. And the main advantage of this GRPO approach is that they reduce computational cost, because they remove this reward model that we also update during the training. But regarding to accuracy, there is no big jump in improving accuracy. Of course, they show that they improve accuracy, but it is not that we expect. And yeah, also when we talk about PPO and GRPO approaches in this form, we talk about reinforcement learning with human feedback. What does it mean? It means that this reward model is trained on preference offline, on human preference data that's annotated by human. And exactly this reward model just imitate human in estimating or rewarding these outputs. And because of that, we have like reinforcement learning with human feedback. And reinforcement learning human feedback show much better results in solving the first problem, if you remember, problem of alignment or satisfying human preferences. But in reasoning, of course, it improves reasoning, but it is not a level that we expect. And because of that, the same guy from DeepSeek, in beginning of this year, in 2025, in January, they just try to improve this approach. How they improve that? They improve removing this reward model and using just a verifiable reward. It is just like rule-based tool. It can be some math verifier, code sandboxes, depending on the task what we solve. And according to this, they just estimate if this output is correct or not. And it's all that they did and improve, but it show very impressive results. What they show in the results, they show that by increasing the number of iteration, the length of the outputs, it means that the number of token and outputs also increase. And it also, by increasing this length of outputs, you can see on this graph that accuracy of solving complex tasks also increase. And it is just confirmation that I talked in the beginning, that in reasoning models, when we generate more tokens in inference time, we can much more improve solving task or improve to receiving correct answer. And I can say that it is impressive that this guy developed, and it is like a game changer that we have today, or state of the art in training LLMs with reinforcement learning. And of course, yeah, I hope that in near future we will receive maybe there is new approaches that will much more better. But yeah, at the moment, this is what we have. And now there is the question: when should we use reasoning models? Firstly, we need to know that by generating each token, it is additional cost. And for example, if you have some simple task, or if you need fast and cheap response, in this case, it's much more better to use instruct model because it is more cheaper. But if you have some complex decision task, or we need deductive or inductive reasoning, or chain of thought reasoning, in this case, of course, it is better to use reasoning models. And I would like to share with you one task that me and my team also try to solve. We try to find all possible independent subset of maximal nodes in graph, and this graph was present London Metro with 426 nodes and 505 edges. It means that each metro station is nodes and each connection between metro station is edges. We tried to solve this problem exactly. We tested with state-of-the-art reasoning models, but we can solve this problem. And of course, this problem is NP hard. What does it mean? It means that if you increase the number of nodes, the number of possible search exponentially increase, and it is very difficult to solve. But also we test this problem on small size graph. And if I remember, maximum, if we have maximum 30 nodes, a reasoning model exactly solve this problem. And it is very impressive because, of course, using some code, we can solve this problem. But solving this problem in natural language, it is impossible for human, I think. And it is very impressive that reasoning model can solve this problem. And as I said previously, that I think in near future there is a lot of more approaches, I hope, and this model be much more and more powerful. And yeah, final message for today from me: use the right type of LLM for your task. And before I finish this presentation, also I would like to say that LightAutoML from exactly my team and our group, this is library LightAutoML that Lyosha in previous presentation talk. You can join to our Telegram channel. And also Tsuru, also this library for solving time series problems. Also we recently put in the open source. You can also join to, I think it is just our framework on GitHub. And I would like to say that if you follow our GitHub profile in summer, I mean recently, we also plan to put in open source data science agent that will solve data science task and also analytic task. And it will be very interesting because maybe all data science analytics will be in problem with their jobs, but don't worry, I think it will not happen. Yeah, and thank you very much. And yeah, now we can start with questions.
Приветики, меня Антон зовут, LLM-очки люблю. Вопрос примерно следующий. Вот мы говорим про reasoning модельки, у нас есть простые модельки, но мы говорим про то, что reasoning модельки, они достаточно часто ошибаются для простых задач, но это же звучит примерно как-то странно. Когда мы придем к такому, что мы будем пользоваться просто одним типом моделей, без разделения на reasoning, не reasoning, или это уже сейчас есть? Спасибо.
Окей, давай я тогда на русском отвечу. То есть ты меня спрашиваешь, если уже есть какая общая модель, которая не понимает. Ну, смотри, пока ты просто зависимо, как тренируешь модель. То есть я не знаю, как у остальных, например, OpenAI, но они тоже имеют отдельные модели, но под компотом, то есть разные модели. То есть как ты тренируешь эту модель. Если она тренировала на reinforcement learning, она будет как более reasoning. Если она только на SFT, она SFT. Но да, интересно, если будут такие общие модели, которые все понимают. Ну, что можно сделать под компотом? Можно все сделать. То есть под компотом могут быть разные модели, и он может понять, какую модель вызвать, и это может делать. Это могут так сделать, сказать, вот эта модель, которая все делает. Но на самом деле это может быть больше модель. То есть все зависит, что находится под опишкой. Но самая модель, как-то это все зависит от тренинга, то есть как ты тренируешь. То есть если только на SFT, она будет как human имитировать человека. Если сейчас это вообще, этот reinforcement learning, это что-то как-то новый способ, это обучение. Так что тут еще много будет исследований в этом направлении. И может в будущем, может даже в близком будущем придумается какой метод, который это будет решаться. Я надеюсь, что ответил на твой вопрос. Вот. Спасибо.
Продолжение вопроса.
Ну да.
Спасибо за доклад, было очень интересно.
Всё.
Правильно ли я понял, что основная проблема с reasoning моделями в том, что они, грубо говоря, overthink вопросы? То есть они слишком, по-русски, заморачиваются над ответом, и поэтому их точность падает. Почему я спрашиваю? Потому что мы недавно делали как раз RAG-чат с агентами, и, соответственно, использовали несколько моделей. DeepSeek R1, DeepSeek, господи, не помню, какая там была предыдущая, Квен и так далее. И проблема была как раз в том, что мы думали, вот у нас новая супермодель R1, сейчас мы ее включим, у нас все заведется. А в итоге оказалось, что обычная лама 4.2, по-моему, она лучше всего по факту работала в этом случае.
Ну, именно, да, что я говорил здесь в конце. То есть, если какие-то простые проблемы, ну, как я не знаю, вы, наверное, не решал там какие комплексные задачи. Это просто было, да, потому что эти простые модельки, они уже, эти данные, которые, что вам нужно, они так на SFT, они уже обучались каким-то образом, и они на этих данных могут достаточно хорошо отвечаться. Но что проблема ризонинга? Проблема, что он, когда он итерирует через тренинг, то есть он этот вопрос, и он пытается решать такой вопрос, но длительным, то есть расширяет число токенов. И, конечно, если отправишь на какую проблему, которая может быть так не комплексная, но когда отправишь это это называется overthinking, она начинает бывает, что она простую модель, да, простую задачу, она может как-то смутиться, то есть не решиться как нужно, но если это есть reasoning модель, чтобы использоваться на комплексные таски, то есть если у тебя какая комплексная таск, что нужно разбиться на несколько, например, что обычная модель не может решить, значит, она пускает, то есть через токены, она из одного токена увеличивает вероятность, и таким образом решать такие комплексные таски. Но на простые таски тебе не нужно reasoning, потому что, как сказать, на простым тасками это SFT очень хорошо работает, потому что он на простом таске, не знаю, просто давай приведу пример. Слушал про AlphaGo. Да, ну что там ребята сделали? Это, значит, модель, которая играет Game of Go. И они там показали, что когда они обучают только на этом SFT, как обычная модель, она просто работает, как на уровне человека работает. Но потому что это Game of Go, она имеет много, сложная игра. Тут можно думать, может, другим образом. Когда они Reinforcement Learning делали, она сделала, то есть она была лучше по качеству. Поэтому хочу сказать, что если у тебя комплексная задача, где тебе нужно разбиваться, например, на какие куски, или просто сделать, как сказать, вообще на простых моделях, я не знаю, что у вас было, но если простая задача, лучше не использовать. Эта проблема овертинкинга существует. Конечно, я говорю, может быть, в будущем эти технику, методы еще улучшатся, и эта одна модель будет, как ответил на предыдущий вопрос, будет решать и простую задачу, и комплексную задачу, как она модель. Но опять может случиться, что они поставят API-шку и сказать, как она будет понимать, если комплексная задача, отправить на reasoning модель, если нет, отправить на эту обычную и скажет, вот у нас одна модель. То есть посмотрим, что будет в будущем, но пока сейчас, если простая задача, не использую reasoning.
Спасибо большое.
Пожалуйста. Yes.